Good day, Professor. Today I talk about the workshop 2 of the course Vehicle Engineer. I am Ramos Otomar Lonjon. On this workshop, it's about the evaluate the suspension assembly. On this workshop, we must to do modify assembly parts, make rigid parts into flexible, and compare the difference in longitudinal wheel displacement by changing the left lower control arm to behave as a rigid body. And finally, explain the plotting about this. Okay, in the first step is about explore so many options. This is very important. We we must to know about this option because it's very important for other workshops. Okay, in the second step, it's about to create a suspension assembly. For this part, you first go to a file options, choose the point in a new options and select suspension assembly. After that, it will appear a box where you write a assembly name. It's subASI. And about the suspension system, you right click and select a car share subsystem, and then OK. After that, we have a suspension system. Okay, in the step 4, it's about introducing flexible bodies. For this, you first select the get lower control. The spelling is very important because you can confuse for get lower control, and this is a problem. Okay, you right click in get lower control and select modify general part. Then it's appear this box. Well, and then you must to choose this option. It's about rigid to flex. After that, it's appear this box, okay, who is about the swap a rigid body for a flexible body. On this part, you right click on this part, you right click here and select this option, LCA right and open. This is about modify carryover control arm for left and right. First is left and then right. Okay. About the connection options, it's about the you must to click on move and then preserve expressions. Well, and then after that, OK and OK. This box is about the managing flexible bodies. You right click on the left lower control and select information, and this is about the information of partial inertia coupling, all the properties, and about the adjust general part and modify, you go to get left lower control and select modify general part. Okay, continuing with the box modify. You right click on the left lower arm and select modify general part, and then you choose this option. This option is about the flexible body modify. Well, on this part you write in the model number the number 9. This is very important because affect in the frequency. Okay, and well, for the simulate, you go to push this part, and you can see how is deformation, how is the deformation on a flexible body. Okay, on this part we can see the deformation of the lower arm. This is about the modified to rigid body. For this, on this flexible body modify, only click on the option rigid body and OK. After that, it's about performing a suspension analysis. You go to review and select suspension analysis static loads and write these values. It's about the braking force who is interacted in the simulate. Okay, and then OK, and the software is calculate about the simulation. Animating analysis results. For the rigid body, you go to simulate and select animate controls. On this part, you can see how is the deformation on a rigid body. Okay. About the plotting analysis result. Okay, continuing with the plotting results of the left and right. In the result of plotting, you must have two graphs of the behavior. The wheel travel to the left and is braking to the left, and similar to the right. Okay, and well, on these graphs we can see how is the length versus force. We can see that in braking the force increase while the displacement while the length advances in both wheels. Okay, workshop questions. Number one, can we have similar results between suspension or any subsystem with flexible parts and rigid parts? About this question, we can have similar results because a rigid body doesn't tend to bend easily, and if it bends, it tends to break. Unlike a flexible body that can have deformation and return to initial shape. For example, if I simulate a spring, for example here, and as a rigid body and apply forces to it, it will not fulfill its function and tend to break. And if we simulate it as a flexible body, we would see we would see how it's changing when applied to it. Another example is question 2. Why we need to perform the parallel and opposite wheel travel analysis? The parallel analysis is because in a straight path, several forces are applied to the wheel in all directions, okay? And if we don't do this, we could have a small variation in the parallel alignment of our tires, generating different force, and with this we are in this, okay? And about the opposite wheel travel is because when you advance a straight path, there are opposing force. So, for example, the friction, this affects the wheel of a vehicle. Well, for the third question is about a problem where we can determine the steady state amplitude of vibration. For this problem, it's important the equations and identify the variables. Okay, for the first variable is about the stiffness is 10 kilonewton. M is about the mass, 2,000 kilograms, and the dashpot coefficient is 2 kilonewtons per meters. The harmonic force of amplitude is 500 newton. The frequency is 0.5 hertz. This value is important to convert in radians per seconds. For example, again, okay. The first variable that we have to find, and its value is 2.23 radians per second. In radians per second. For this step, it's important the conversions of units, because if you don't convert conversion of units, you have a problem. Okay. The second variable is about this is 1 over Q. Okay, this has and this has no units, and the value is 0.22. And for the final equation, we have to replace all the variables found, and the the result is 0.0434 meters. On this part, as we can see, the amplitude of our spring is this value. This indicates the maximum displacement that the spring has applied to the force. Okay, thank you.